Hello class, we are into week 5 of statistics and this week is all about confidence intervals. When we get information, usually it is from a sample due to cost and time and just availability. And we'd like to be able to infer from that sample that it applies to the population, and we can do that with a confidence interval. And that's what we'll be learning how to do this week. So here's an example that I just grabbed off the internet. This was a poll taken last year right after the breaking in of the U.S. Capitol, and it says among 964 registered voters. So this is their sample size, n equals 964. And the question was, do you think the breaking into the U.S. Capitol building was mostly incited by President Trump, or was it mostly the actions of a mob of people? And red, this part of the pie, 45% indicated they thought it was incited by Trump, and 55% said it was mostly the mob. So from that sample of 964 registered voters, that's the information they received. This is our margin of error. This is what we use to create a confidence interval, plus or minus 3.16 percentage points. And this is what we're going to learn how to calculate. Confidence intervals are at different levels of confidence. Typically, it's 95%. So if it is not explicitly stated somewhere, that is what we assume, a 95% confidence. It might be 99, it could be 80. It could be a myriad of different numbers, but typically 95 or somewhere in the 80s or the 90s. So what this is saying is that with 95% confidence, we can say the population percent that thought it was incited by Trump is 45% plus or minus 3.16 percentage points. We can say with 95% confidence that the proportion that thought it was mostly the mob is 55% plus or minus the 3.16 percentage points. So to create these intervals, where we believe 95% that the population would fall within, we just take these 3.16 percentage points, we subtract it and add it to each of our values. So Trump, 0.45, I'm converting it to a decimal, subtracting 0.0316, and I'm adding 0.0316, and that gives us 41.84% and 48.16%. I can say with 95% confidence that the proportion of individuals or registered voters that think Trump incited the breaking in of the U.S. Capitol is between 41.84% and 48.16%. Likewise, we take that 3.16 points, convert it as a decimal, subtract it from the 0.55 for the mob, add it to the 0.55 for the mob, and I can say that with 95% confidence that the population percent of people that felt that this breaking in was mostly the mob is somewhere between 51.84% and 58.16%. So that is how we use this margin of error that is seen right here. So I'm going to walk through doing this manually, and then we'll go and we'll do it using StatCrunch. So margin of error is also called the error-bound mean, EBM, and we use that margin of error to create our confidence level. Typically 95%, but it can be anywhere between 70 and 99%. If we know the population standard deviation, we can use this formula over here, which uses a z-score at a particular confidence level. So if you went through the slides for this week, you would have saw this table. The z-score at a particular confidence level is a constant. It doesn't change. It doesn't have to be calculated. Typically, you would see it in a table like this. So if we wanted to calculate something at an 80% confidence level, the value we would use for the z over here would be 1.28. So this is a formula that we can use to calculate E, which is our margin of error, when we know the population standard deviation. We just use the z at a particular confidence level, that's these values over here, multiply it by the standard deviation, and divide that by the square root of n. So in this example, we have a sample size of 36, a sample mean of 10, and a population standard deviation of 0.8. And we're going to construct the confidence interval. Just a little side note, you're always going to be given a mean or a proportion because that's what you use to create the confidence interval, but that mean is not used in the calculation of the margin of error. If you look up here, we're just using a z-score, a standard deviation, and a sample size. So for 98% confidence, I'm going over to my table, that's 2.33. I'm plugging that in for the z. I'm multiplying that by my 0.8, which is my standard deviation, and I'm dividing that by the square root of 36 because that's my sample size and I get 6. That gives me a margin of error, or the error-bound mean, of 0.311. So that's my margin of error. That's my plus or minus value. To create the confidence interval, that's where the sample mean comes into play. We subtract it from the sample mean and we add it to the sample mean. That gives us 9.689 and 10.311. So this, at the bottom, these two values, this represents my confidence interval at 98% confidence. So I can be 98% confident that the population parameter, the population mean, would be between these two values. All right, now let's look at when we don't know our population standard deviation. In that case, the formula looks very, very similar, except we're using the sample standard deviation and we're using the critical value t. If you went through the slides or the work, you would see that we can, again, it's contingent on tables. The only difference when we're using a table trying to find this t value is that we are using degrees of freedom, which is just your sample size minus 1. So we need to find our t at 95% confidence, given a sample size of 16 and a sample standard deviation of 0.8. So I gave you this link in the slides this week, but I think I have it open over here somewhere, and I do. So if you go to that link, you're going to come to a screen that looks like this. And remember, degrees of freedom is just sample size minus 1. So our sample size is 16, so we're going to put in a 15 here. And the significance level is 1 minus your confidence. So if we want 95% confidence, we're going to put 0.05 in here. And we're going to calculate. And where did my value go? Oops, sorry, there it is. So we look at two-tailed. And so for a degrees of freedom of 15 and a 0.05 significance level, we have a t-value, these are my t-values, of plus or minus 2.13. We'll round it to 2 decimal places. So we have 2.13. We come back over here. We use that for t. Again, we multiply it times, now it's a sample standard deviation of 0.8, and dividing it by the square root of n, which is 16, so that's 4, and that gives us 0.426. To create our confidence interval, we subtract that from our sample mean, which is 10, and add it to our sample mean, and we come up with this confidence interval. So with 95% confidence, I can say that the population mean would be between these two values. And one other type of confidence interval is with a proportion. You'll see that your discussion question this week is asking you to create it. So I'm going to go through the process with some made-up values here. Examine a current magazine such as Time or Newsweek and find the proportion of pages that include advertising. Based on the results, construct a 95% confidence interval, that's the most common one, of the percentage of all such pages that have advertising. So this is about a proportion. If you went through the material or my slides, you would see that we have this formula for calculating a margin of error for a proportion. N is your sample size. X is the number of successes, however it is defined. So in this example, a success would be a page that has advertising on it. P is the probability of success calculated by x divided by n. Q is a probability of failure, which is just 1 minus your probability of success. Z is the critical value based on the desired confidence level. So that's that table, that constant. So for 95%, it's 1.96. And we calculate E differently for a proportion. It's that Z value times the square root of P times Q divided by N. And then to calculate our interval, we subtract E and add E to the probability of success. We don't have a mean. In these examples, we're talking about a proportion. We're talking about a percentage that defines success and failure. So just like the first slide when we had 45% and 55%. When we're talking about percentages, we're talking about proportions. So we're just going to pretend like I had a magazine that had 80 pages. And if 20 of them had advertisements, I would say X equals 20. And I would calculate P, the probability of success, 20 divided by 80, which is 0.25. I can subtract that from 1 to get Q, so I have 0.75. And then I plug these values into this formula over here, 1.96 times, and then it's just a square root of 0.25 times 0.75 divided by 80 because that's my sample size, and then just doing out the math, I come up with 0.094. That's my margin of error. For my confidence interval, I subtract that from the probability of success, which was 0.25, and I add it to the probability of success, and I come up with 0.156 or 15.6 and 34.4 as my confidence interval, my lower bound and my upper bound. So we can state with 95% confidence the proportion of pages in a magazine that have advertisements is somewhere between 15.6 and 34.4%. So now let's just do these same examples, but we're going to use StatCrunch. So let me go back over here. Sorry for the flipping around. And first we'll do the one where we use the T critical value. So we go to Stat, right here where it says T Stats, one sample, and we're doing summary data. We're not typing in, we don't have all our numbers and calculating means. We just have summary data. So with summary, and the sample mean in this case is a 10, and I'm taking this right from the example. Standard deviation is 0.8. Sample size is 16. And I'm going to click the confidence interval button. 95% is correct. You can overtype this, whatever you need to do. And I'm going to compute. And I have a lower limit of 9.57 and an upper limit of 10.42, which is what we came up with. So a lot easier to do it this way. So that's using the T critical value. And now let's do it for this example here where we're using Z critical value. One sample, summary, and we have a sample mean of 10 again. And we have a sample standard deviation of 0.8. We have a sample size of, 36. And we're doing 98% confidence. You got to click on that button. We can type that in, and I'm going to say compute, and that gives me my 9.689 and 10.31, which is what we got over here. Again, a lot easier going through StatCrunch. And now let's do it for the proportion. Stat and proportion stats. One sample with summary, and we have number of successes is 20. That's our X value. I'm having a hard time seeing that, sorry. Okay, so that was a 20. And number of observation, that's N. That's our sample size, which is 80. And we have a confidence interval at 95%. And I'm going to click the compute button. And here we have our 0.155. We came up with 0.155. Got 156. That's okay. Probably due to rounding. And 0.3448 or 345. Again, that's okay, probably just due to rounding when I did it manually. So that's the process for doing it manually and or doing it using StatCrunch. Hope that helped, and let me know if you have any questions.